So, ionic or electrovalent bond. We are going to study this today. So, from the Causal and Lewis treatment of the this is lecture 5. Sorry, to interrupt me. Lecture 5. Let us start. From the Causal and Lewis treatment of the formation of an ionic bond, it follows the formation of ionic compound would be primarily depend on the ease of formation of the positive and negative ions from the respective neutral atoms. The arrangement of the positive and negative ions in the solid, that is the lattice energy of the crystalline compound. The formation of positive ion involves ionization, removal of electrons from the neutral atom, and that of the negative ion involves addition of electron to the neutral atom. This is ionization enthalpy. This electron gain enthalpy means in this process, this atom gains electron. In this process, lose electron. This process is exothermic. This is endothermic. Here delta H is positive. Here delta H is negative. And this is a formation of ionic bond, right? Electron gain enthalpy. Example H. Changes enthalpy change unit 3 when a gas phase atom is in its ground state gains an electron. The electron gain process may be exothermic or endothermic. The ionization on the other hand is always endothermic. The electron affinity is always negative of the energy change accompanying electron gain. Obviously, ionic bond will be formed more easily between the elements with comparatively low ionization enthalpies and the element with comparatively high negative values and electron gain enthalpy. Most ionic so now what this point means to say is that when the element have low means the anion, which is the anion, when this has the greater ability of losing an electron, and anion, and here is anion which has greater ability of gaining electron, then they form ionic bond very easily. So it becomes very easy for them to form ionic bond. Most ionic compounds have cation derived from metallic element and anion from non-metallic elements. The ammonium ion NH4 plus made up of two non-metallic elements is an exception. It forms cation of a number of ionic compounds. Ionic compound is crystalline state uh, consists of orderly three-dimensional arrangement of cation and anion held together by Coulombic interaction energies. These compounds crystallize in different crystal structures determined by the size of the ion, their packaging arrangement, and other factors. The crystal structure of sodium chloride NaCl, for example, is shown below. Right. So this is the complete structure of NaCl. First of all, I would like to make a important point. I'd like to underline this. This is important, right? So NH4 plus is made of two non-metallic atoms is an exception. It forms cation of a number of ionic compounds. So what this means to say is that NH4 plus is ionic bond, but both are non-metal, right? Then also they are ionic bond. Now this red part is Na plus and Cl minus is the blue part. So now where does Cl occupy? You can understand Cl occupies at the corners, four corners, and the face. One electron in the face. So right, how many electrons would be there? One, two, three, four, five. Five, right? So 5, 4, 5. Total 14 electron. 14 chlorine anion. Sorry, not electron. I'm sorry. Right, and in the case of sodium, 1 2 3 4 4 5 4, right? 4 to the 8, 8 plus 5 13, 13 anion, right? So ionic solid and the ionic solids, the sum of electron gain enthalpy and ionization enthalpy may be positive, but still the crystal gain gets stability due to energy released in the formation of the crystal lattice energy. For example, the ionization enthalpy Na plus formation of Na is 495.8 kilojoule per mole, while the electron gain enthalpy for the change of chlorine plus electron Cl minus is minus 348.7. Only the sum of the two is 147.1 kilojoule, more than the compensated for the enthalpy of lattice formation of NaCl minus 788 kilojoule per mole. Therefore, the energy is released. A process more than the energy is absorbed. Thus, qualitative measure of the stability of the ionic compound is provided by its enthalpy of lattice formation and not simply by achieving octet of electrons around the ionic species in gaseous atom. What this means to say is that to achieve stability of an ionic compound, provided its enthalpy of lattice formation and not simply by achieving octet of electrons around the ionic species in the gaseous atom, right? So means whenever you achieve octet configuration, whenever compound achieves octet configuration in its outermost shell, so it must have some like lattice energy so that it can sustain. If it has very low lattice energy, then the bond will break very easily, and which means that it is least stable, right? So to have the greater stability, we need to have lattice energy. So greater the lattice energy, least is the lattice energy is directly proportional to the stability, right? And lattice energy is directly proportional to sum of product of charges, P of charges by size of cation plus anion, right? That is very important. Since lattice enthalpy plays a key role in the formation of ionic compound, it is important that we learn about it. So lattice enthalpy we will be covering in the next lecture. Bye guys.